About 40% of the energy consumed in a typical house is used for ventilation and air conditioning. Newer technologies focus on efficiently cooling or heating large areas of a building to an average comfortable temperature. But since the occupants only occupy a small fraction of the building and have different concepts of a comfortable temperature, these appliances continue to ultimately waste a lot of energy without providing superior comfort. Thus, there is a critical need for technologies that localize thermal management to the individual level to not only enhance the individual comfort but also reduce the energy consumed for air conditioning. To address this, the team from Kestrel Materials of Otherlab is developing thermally adaptive textiles that passively change thickness and insulation in response to the local thermal environment. Otherlab's fabric fluffs up and increases insulation in response to the cold and goes back to a thinner state as it is heated up. The insulating layer of the fabric bends and flattens based only on changes in temperature, as opposed to a similar mechanism adapted by Zhong et al., which utilizes the swelling properties of Nafion polymers in response to surface humidity due to the wearer's sweat. The fluffing mechanism of Otherlab's fabric is based on the bending ability of a bimorph textile structure constructed by weaving two fibers with a significant difference in thermal expansion. One fiber expands or contracts faster than the other, which creates a tension in the structure, allowing it to change its shape. A fabric sample increases its insulation from approximately 0.5 CLO to around 1.2 CLO in response to a temperature drop from 27 to 17 degrees Celsius, accompanied by a change in area of no more than 5%. This change in thermal resistance is equivalent to the feel of wearing a t-shirt and a pair of pants and then changing to a heavy office attire. Since these changes are a result of the difference in the fiber's thermal expansion, the change is therefore purely passive and requires absolutely no input from the wearer. The thermal response can then be adjusted to fit various climates by varying the combination of the fibers used. This is the patent for Otherlab's thermally adaptive fabric. Although first of its kind and the thermal performance is already quite impressive, the texture, drape, breathability, stretch, and overall fabric feel still need to be improved. This can be done through thoughtful material selection of the fiber and the structural modifications such as the tightness of the weave at the fabric level. Although Otherlab's target market is indoor apparel, this insulating technology can be applied to outdoor gear such as tents, sleeping bags, and military clothing to provide needed insulation without the extra baggage. A similar bimorph concept can also be applied to tire exteriors to allow the grooves to expand and increase friction during inclement weather.